I'm looking at our to-do list for this text analyzer project, and before I get into the content that I said I would put in the video, I want to deal with another problem that I've discovered. And I don't know if you've noticed this or not, but there's a really interesting DRY violation inside this project. You can actually see it here, but it might be easier to look at the code. So let's go and look at analysis. So our analysis gives us three responses because that's what our requirements document said. It said we needed a number of words, the number of unique words, and the frequency map of word to how often it shows up. It turns out this is a structural DRY violation. We have the same information represented multiple times. And let me explain to you what I mean. So the frequency map is going to be a mapping from each individual word to the number of times it shows up. But each individual word will show up exactly once. So the number of unique words is actually the number of keys in this map. And I thought that was the only problem actually when I started the video, but as I get into this, there's another problem. The number of words is actually going to be the summation of all of these integers, right? That has to be the number of words in the string. So we have a really interesting DRY violation. We went from the requirement specification to the code, and really this we hadn't taken this out before. So because I found this violation, before I do anything else, I want to refactor. I want to keep my code clean. So how should we do that? It seems like our primary data may actually be this frequency map. So let's see, we could start by kind of putzing around in here, or we could go over to our tests and start oh, we don't need that learning test. We could go to our text analyzer test and start changing that. But I want to point out another interesting problem that I sort of backed myself into. When we thought that these fields were just going to be available for everybody to read, we made them public final fields, which sometimes I use, but there's a problem there because we can't change the implementation of them very easily. We're binding all of our other code to this. I think what's going to work best is if we just sort of gut this implementation of analysis and have it work with accessor methods instead. The nice thing about accessor methods, so let me show you what I mean. If we have a public int count words, or maybe you want to use a accessor notation like get word count, that's fine. This right now could just return words, and that's fine. But if we wanted to change this implementation to, for example, add up the frequency of all of the integers in this map, we can change that here, but we can't change this, right? By making this public, everybody is tied to our structure rather than our behavior, which actually is a violation of good design, a violation of good object-oriented design. Okay, so let's get down to brass tacks. How do we want to do this? Should we let's just change this. One option would be to go in and revise the tests and match those, but this is kind of a major overhaul. So since I'm here, I'm just going to start cutting this out. And my argument here is now going to have to be a map from string to integer. Oops. My frequency data, and I'll say this dot frequency is frequency. By the way, this is a problem. What I have right here, this is a leaky abstraction, but we're going to deal with that next. I'm going to try to solve one problem at a time. So for now, we'll go ahead and do this. That's a leaky abstraction in case you want to look that up. So what's our word count? Our word count is actually going to be the sum of the integers in that map. So I can just do that very easily like this. Oh, in fact, maybe you don't know about some of these map APIs. The Java collections library, java.util stuff, is really, really handy. So we really just want to go through all the values and send them up. So I can say for every integer I in frequency values, see this will give us back a collection of all the integers. I can say count plus equals I, and my result is count. There we go. Now this has maybe a slight downside that we recompute it every time we call this method, but again, I'm not going to worry about that performance right now. It's not a problem. So there's my get word count. Let's change this to get count unique words. So the number of unique words will be the number of keys within my map. So I can say for every string s in my frequency key set, add 1 to the count. Easy, easy. So the last piece is dealing with the frequency. And again, even though it's going to be a leaky abstraction, I'm just going to take the kind of lazy approach for now, because we can always clean it up later. First, I want to get all the other pieces in place. So if I say get frequency, I'll just say return frequency. Okay, knowing that that's a problem, we'll fix it later. So if I restructure analysis this way, then my text analyzer needs to be restructured, and the compiler here gives me some hints about where I need to go. Number of words is 0. This is now count, get word count. And this is number of unique words. This is get count unique words. And this is get word count. That wasn't so bad. Let's run our tests. Oh, some pieces still not compiling. That's okay. Here's that little main method that we wrote. This also has to change to get word count, and this can change to count words. Okay, let's try again. Oh, still not quite there. Let's see. Cannot convert an int into a map. Oh, of course, because this is where we do the actual analysis, and we're not sending anything meaningful in there right now. So how do we rewrite this implementation so that my tests pass? Well, let's see. Let me keep that split method. Okay. So I'm going to use Control-Alt-L here to format the file. Okay, so that gives me the split of all the strings. Let's just kind of iterate through the array there. So I can say for every string s in my split string, we're going to need a map to fill up here. So let's make a map from string to integer, and that'll be a new hash map. From let's see, we'll add in further types. Alt-Enter, we'll do the import. No, I won't infer the types. Okay, string to integer. Good. Oh, S is already named here. Let's rename that to input. That looks a little nicer. Okay. So now we just have to do the actual heavy lifting here. We're going to go through everything we split out and see if we can put it in the map. Let's do this in the very naive way. We can just say map.put s1 and then return the map. Now this obviously doesn't work for having multiple instances of strings, but my test cases don't worry about that yet. We're solving a simpler problem before we solve the harder problem. This will be return a new analysis built around that map. That compiles, so again let's try this and see if it'll run. Great, so the application runs and we have some tests failed, which is great, that's what we want. So let's see. What test is this? Analyze empty string gives us 0 words. This is coming back and saying 1. Oh, this is that same problem we saw before where the empty string is still a string, but we don't actually want to process it. So we can say if s.isEmpty, or maybe a better way to say that would be if it's not empty, then we'll do that. So this should allow us to skip the empty string. Great, so all my tests pass after this refactoring. But again, because I was doing this refactoring, I may have introduced some other ugly code. So let's think about this as red-green refactor again. So through these changes, have I introduced any other problems? That actually happens pretty often, that in the process of improving the structure, you might have to break a couple of things in order to make them better. Okay, so let's look at, local changes. Now remember, you can use Control D here to see the difference. That's probably off the screen capture area. You can do show diff, and that'll show you exactly what's different if you want to just focus on the changes. I'm just going to do this by inspection though. We don't actually need this anymore. This, rather, it doesn't have to be public. I'm going to hide that within my analysis object and only access it through the accessor. Now that leads us to this interesting problem where we are copying a reference to this map that is being sent in from the outside world. That means that somebody else could change that map and therefore change our analysis results. That means we have a leaky abstraction here, and that's a problem. We really want to make what's called a defensive copy here. So when somebody sends us an object like this, we don't want to just hold on to it. We want to make a defensive copy. So let's do it. It looks like this. We'll go through and copy everything from frequency and put it in our current map. So we can say this.frequency dot add put all, and I think we can just take that other frequency like that. So instead of aliasing, that's a really important word. If you're not familiar with that, look it up. Instead of aliasing the map that's sent in, the frequency map, instead we're making a defensive copy. Okay, good. Similarly over here, we don't want to return our actual internal data structure, because if somebody on the outside that receives it makes a change, that makes our analysis object suddenly broken. That's no good. So instead, we will again use a technique of defensive copies here. So we'll return a new hash map, and I'm going to use Control Q here to see the different constructors. Notice that there's a constructor here that takes another map as an argument, and that's called a copy constructor. It's used for making defensive copies. So as you can see, this constructs a new hash map with the same mappings as the specified map. So we will return a defensive copy, and then we'll know that nobody else can modify that object. Great, that's much better. Quick look over here. We're going to change that to get frequency. Over here, this looks okay. I'm a little concerned about there being two levels of nesting here. So we have a for loop, and inside an if statement. If you have nested control structures, that almost guarantees that your method is not doing one thing. However, this method is very short. There's only, I would say, 1, 2, 3, 4, 5 lines plus a return statement. So for now, I'm going to leave it like that. In part also because I know that I'm going to have to make some changes to it very soon. So I could go through the effort of pulling that out. I don't think I'm going to do that now. How do my tests look? Again, we'll just do this by inspection. Oh, something's actually broken down here. Oh, again, this is using the previously public field. Instead, now we'll say get frequency. And those are the only changes there. So I will run all my tests. Great. That's much nicer. And this is a good example of good object-oriented design too, where we're building this analysis object, but we're not just using a data structure approach of having a lot of public data. Instead, we have these messages that this object understands, these methods that provide functionality. So that's nice. All right, let's commit it. Let's see, commit. Make sure my author name is set properly. And we'll say this is refactor construction of analysis objects. Actually, it's not just a construction analysis object. So that's a short message, right? Our commit messages start with these little short 50 character or less summaries. But maybe I want to say a little bit more about this. Okay, that looks good. I'll commit. And oh, rats. And now staring at me is this compiler warning. I missed that. You know, when you're going through and looking at changes before you commit, you've got to look for the little yellow box there. That means there's a warning. Let's see what I did wrong here. Oh, that parameter is never used, right? Because I'm just counting the number of things in the key set. I think there's probably an easier way to do that. We could just say return frequency.keyset.count size. There. And does that still pass? Okay. So once again, I've shown this before. Make a little change like this because you missed something. You can do what's called amending the commit. So that doesn't make a new commit, it actually edits the previous commit. Now, that can cause serious problems if you've already pushed, but fortunately I didn't push, so this commit only exists on my hard drive. That's not going to hurt anybody. Okay, so this video is already kind of on the long side, so I'm going to keep this one just focused on that refactoring, and I'll make a follow-up video where we look at those other two test cases. Thanks for watching.